My name is Fred Blaine. I'm the product manager for driller optical geophysics here at IMDEX. And I'm joined by James Cleverly, who is the global product manager for geosciences. We've had a large amount of interest in this webinar, and I'm glad that a lot of you were able to join us this afternoon. So throughout the presentation, James and I will be talking about some simple to use but powerful workflows that can be used using real-time data to improve the core logging process. Throughout the presentation, James and I will switch back and forth a bit. Throughout the presentation as well, because there's a lot of us in here, everybody who's in the webinar will be muted. If you have any questions, just drop them into the questions field, and we'll try to answer them either during the presentation if we see them, or there'll be time for questions at the end. So first off, I'll hand over to James, and we'll get started.
Right. Hello everyone, welcome to this. So Fred, if you just jump to the next slide, yeah. So I guess anyone who's heard me talk at all about any of this will have seen this diagram, but one of the challenges we're facing in our industry really is the problem of time. And that is that we go and drill a hole, not to the sake of drilling a hole, but we go and drill a hole because we want to take a sample. And we want to sample that geology, to measure properties in that geology, to then use that to make an interpretation, turn that measurement into information, make an interpretation as geoscientists to make a decision. And then we go around that cycle again. And the drilling cycle is really a risk cycle as well. It's a risk decision cycle. So we're minimizing risk as we go around that cycle in any of our programs. And it doesn't matter whether you're in greenfields exploration or drilling a blast hole bench in a mine, that cycle still exists. Now the time to move around that changes. But in all cases, really, one of the challenges we face in our industry right now is the time to move around that cycle, the time to give geoscientists the information they need to make critical decisions is probably too long. So one of the things that we're doing in IMDEX is really addressing that with both technological and software infrastructure to try and address this cycle, because one of the things that you tend to find is that people shortcut this cycle and then don't have the information that they need to make that decision. Or don't have the quality of information they need to make that decision. So starting to log core, for instance, without any form of background information. So Fred, if you just click the next slide. And the next one. One of the critical parts of solving that problem is to get data where you need it. To get data where you need it in the form that you need it in. So one of the things that we've been doing in IMDEX is developing our IMDEX Hub system, which is about transferring data in a seamless way through to provide it in the way of information to the geologist. So the traditional method of taking a downhole tool and pulling that survey data off on a USB stick, for instance, transferring it to an on-site computer, email that raw data to a DBA and put it into the database, get it categorized, and then people start to look at it. That whole process takes time. It's not a secure chain of custody. We have issues with how we transfer that data, and then it means you don't have anything available to you when you start the process where you need that data to you. So by putting infrastructure in place to allow data to transfer through systems like IMDEXHUB, and not only that, to then turn that data into information, because we can't overwhelm people with data. We need tools to take data and turn it into information, and then have that information at hand when we're first looking at those rocks. That will support us to make the right decisions and the critical decisions. So, Fred.
What we'll be talking about today is one of the ways that we can get this real-time data into the hands of geologists and knowledge associated with that into the hands of geologists at the time that they need to make a decision. And what we'll be looking at is our Easy Gamma tool and the workflows associated with it. So if we start in the top left-hand corner here, we can take a gamma survey at any time during the drilling process, whether it's mid-hole or at the end of the hole. It's not required that there are no specialized service providers are required. These are driller operable tools. The data is, the gamma data is received within minutes on site, and then it's transferred using proprietary apps to the secure cloud-based IMDEXHUB-IQ. From that, from IMDEXHUB-IQ, your project information is visible anywhere at any time, almost instantaneously, anywhere where you have a web connection. You can then take that data quickly into tools such as ioGAS directly from Hub to start analyzing the data. And there's tools within ioGAS that can really provide consistent and repeatable processes and essentially output a first pass quick log that you can hand to your geologist logging the core. In the interest of time, we won't go into detail about everything, but we'll take a bit of a helicopter view of each of these steps and then focus primarily on the workflows within Hub and ioGAS to provide these outputs. So just firstly, some gamma fundamentals. The Easy Gamma probe is a total count gamma probe. So it measures a range in the gamma spectrum across from just under 0.5 to about 3 mega electron volts. And what this tool does is it measures naturally occurring radiation from the decay of potassium, uranium, and thorium and their daughter products in the rocks surrounding that probe. It's only measuring those 3 elements, but because the ratios of those 3 elements vary quite a bit between different rocks, you get very strong variations in lithology, but also in processes. So it's sensitive to hydrothermal processes, alteration processes. Total count gamma, it's useful across various deposit types. And it goes from direct detection, which is where it's been used historically for things like uranium, mineral sands, as well as coal. But historically, it was limited to, its use was fairly limited to those direct detection things because of the associated costs and time taken to get that information, because you required specialist logging crews with specialist equipment to come out and take those surveys. Having it driller operable and usable in any scenario at a reduced cost, it allows us to broaden the use of it where it's collected way more routinely, and you can start looking at different applications of it where you're picking out alteration processes through to lithological discrimination. In the gamma probe, you pick out really subtle variations in the composition, and these are evident at a fine scale. So we're looking at the order of approximately 10 centimeters. And as well, if you're comparing this to measuring core, it measures a fairly large sample volume, so you're getting a much more representative analysis of the volume of rock surrounding probe. So for the Easy Gamma, just some basic specs of it. It's a passive downhole tool compared to gamma, which is sometimes confused with it, that measures density. There's no active radiation source, so there's no regulatory requirements for it. What makes it driller operable is it's battery powered, it's rugged, and it's a memory-based tool. So no wire lines required. It can be run on a simple cable winch that most rigs have. There's no specialized logging crew required. And because so that there's consistency between tools, each tool is API calibrated. So, you know, if you take one tool and you swap it with another tool, you'll get the the same results. So you don't require that specialist to be looking at the data. Another thing that is good about the EasyGamma is it can be run simultaneously with the reflex gyro survey tools. So you're collecting both your gamma data and your survey data in a single run with a single app, which I'll talk about in a minute. And as well, it's very fast to set up and it's very fast to deploy. So less than 15-minute setup, and deployment is up to 10 meters a minute before you start to lose some of the data quality. If you're running really long holes, you can vary this because you run an in-run and an out-run as a quality control check. But because it's just used as a quality control check, you can run your in-run faster and your out-run slower, or vice versa. Once the data has been collected by the driller, we want to make sure that that data is of good quality. There is nothing wrong with the survey itself. And so we've developed an app that runs the data. So it provides some in-field QA/QC checks. It has some automatic checks. So here we can just see one that's flagged where the in and the out depths are different by 1.7 meters. This would indicate there might be a problem with the cable contacting the encoder or something like that. But when these issues are flagged, it flags to the driller that there's a problem, and they can rerun that survey immediately, and you don't have bad data coming into Hub. If the data is deemed okay and it's sent to Hub, all those QC flags come along with it. So you have a good record of what happened during the survey process. Typically, for the QA/QC checks, you can compare the in and the out run to see if your peaks in your gamma match up. That's the simple QC check that the drillers can do. And then if everything checks out, it can be synced with Hub. Survey-IQ, which is the app that runs these tools, it's a single app and it runs multiple tools. It has direct and secure transfer to IMDEXHUB-IQ, removing the need for USB sticks and CSVs and such. And there's a secure chain of custody, so you know that you're getting unadulterated data going into IMDEXHUB-IQ. So right now, I'll just switch to IMDEXHUB-IQ and just give you a brief demo and look at some gamma data in IMDEXHUB-IQ. So I won't go into too much detail about IMDEXHUB-IQ, but I'll just give you a brief overview of it. What I'll note now is we do have a number of videos on our website at reflexnow.com that are really short, succinct videos that just go into details and what the features and benefits are of the Survey-IQ app, the IMDEXHUB-IQ, or the EasyGamma, as well as a number of our other tools. So coming into IMDEXHUB-IQ, the first thing you see is a splash screen. Gives a world map with the locations of all your active projects. You can see which projects are active in which countries. It also has a ticker to show you any new data that's been received, as well as some notifications. So IMDEXHUB-IQ, it's a cloud-based system that enables the transfer of data, a secure, validated data from field tools to IMDEXHUB-IQ, and it makes the data accessible to end users through an internet connection. Outside of that, though, there's a lot of workflow planning and control that you can set up. So here there's a planning section where you can plan your projects, you can plan your drill holes. Once you've set up these projects and drill holes, these can be synced to the tools. So you're no longer relying on the drillers to enter data. All that data is pushed down from Hub to the tools, and so everything's consistent and validated. If when the driller's collecting the data and he's got the project and the drill hole, and that's identified by Hub, so that data will go directly into that associated drill hole or project in the drill hole. If it's not, then it goes into an assign bucket where you can manually assign those to whichever holes and projects they belong to. If you want to reassign data at some point, you also have the ability to reassign. After everything's assigned where it should be, we come to the approve, and here's where we'll start to look at the gamma data. I've uploaded a couple gamma surveys in here.
So under the Approve tab, we can just select Gamma. And in here, we can see the two drill holes that I've uploaded earlier today. So HHDC and SW09. So here we can see we have a single outrun for HHDC, and we have both an in and out run for SW09. If we select both the in and the out run for SW09, we can create the plots. And this generates a couple of plots of the data showing both the gamma trace and the speed trace. So these are the two main plots that we use for quality control purposes. Both the plots are dynamic and they zoom together. So we can change the area that we're looking at. And what you're looking for on this plot is that both the in and the out trace match. So here we can see the peaks are matching at the equivalent depth. We've got 3 peaks down here. They're all matching up exactly. So we know we've had a good survey and the data quality is good. You also want to look over here to just see if you've got any widely varying speeds. These are extremely consistent speeds, so everything's good here. Once we've looked at that and we see everything is good, we can then approve those surveys. And we can just go OK. And otherwise, if the data quality is not good, we can just reject them. After approving the survey, we can come to View, and this is where we set up the data either for export or if we want to import it into ioGAS, which we'll be doing later. So here, those holes were sitting under Project Webinar. And the tool we're looking at is EasyGamma. So we'll just select that and then view the data. So there's our 2 holes. We come down, we can see our different runs. From here, if we just want to export this table, we can just export it as an Excel or CSV file, and that'll give us a summary of the runs that are there. We can also generate a last file. So this is if you want to bring it into some downhole plotting programs or the like. So here we can just select our interval, which surveys we want to export. Just select that last one, update that, and then we can just download the files, and it'll download a zip file of containing those last files. So what we want to do now, though, is we want to make the data that's in these holes accessible to ioGAS. So how we do that is we save the search. So here we've set up our project, our tools. If we wanted to pick a particular date range, we could do that as well. But here we're just going to save search, give it a name. For this, we'll make it public. If it's private, what it means is only you can see that saved search. If it's public, then anybody who has access to that project can also see that saved search and use the data in GAS or quickly come back to this view within Hub. So we'll just save it, and that's all we need to do in Hub.
Once we've got the data in Hub, we've looked at it, we've approved it, seen that everything's good. We can then bring that data into ioGAS and start doing some analysis on the data. So in order to get the data from IMDEXHUB-IQ, you need to set up a saved search within IMDEXHUB-IQ. And what this does is it allows access for ioGAS to go in and grab that data. So in the File tab in ioGAS, if you click on the IMDEXHUB-IQ sign, it will come up with this prompt for your username and password. And then it will go to Hub, grab those saved searches, and make them available. So today I'll be focusing on the just a couple of the tools to use to work with the gamma data. There's a lot of other tools within ioGAS, but that usually takes a couple days to go over, so I won't be covering that in the webinar. So here I've saved a search called Webinar 2. I can just grab that data. And here it comes in, and the first screen that comes up is this column properties. With gamma data, this isn't as necessary as working with geochemistry data, because there's a number of tools in ioGAS for geochemistry data that require aliasing of the data. But here we can see all our data. We've got depth and gamma, everything's coming in as numeric. Sometimes if you have a rig name that's numeric, it might come as numeric. If you want to categorically, you can change that to text. But here we'll just bring in this data. Here we can see, I'll just attribute it based on drill hole, and we can see we have 2 drill holes here. In the data, we also have both in and out surveys. So what we want to do, we'll just look at the out surveys at the moment. So we'll attribute based on direction and just turn off the in surveys. If we want to just view the data.
Probably worth saying at that point, Fred, in deploying the gamma tool, you can certainly run an in and an out survey, get the driller to run an in and out survey as a way of doing QA. If you're on longer holes, or you're pretty comfortable with the deployment method and you think everything's working pretty well, you can just drop the tool down pretty quick and then pull it out slow, which seems that's probably the best way to do this if you want to cut down the survey time.
Yeah, and as I mentioned, if you still want that QC check, you can run one run fast and the other run slow, and that just gives you because you'll lose some quality in your data because you're running faster, but it'll still give you enough information to compare to see that you didn't have any cable slippage or there wasn't any errors in the logging itself. So here, if we just want to view some data, we can select the variables, select gamma, apply that or okay, and then just to look at the downhole plot, we can set that up. We can look at both holes or a single hole, and here we can see the data. So these are 2 different surveys that were done. This is a very deep hole. This was almost a 3,000 meter hole that was drilled and surveyed with gamma and gyro, and this is a shallower water well. So here we can zoom in dynamically on the data, and we can see there's a lot of texture in the data. We can see some definite features in the data, but how we really draw those lines, if you have 5 different geologists looking at this, it'll be the same as logging core. You'll probably get 5 different answers of where to put the lines and what to do with that, but that's why some of the tools within ioGAS become quite powerful. So here I'll just shut this down, go back to the attribute manager. So now, because to use the tools, what we need to do is we need to we can't have duplicate depths, and because we're running an in and an out run, we'll have duplicate depths. So what we want to do is we want to run a filter on the direction here. So we'll just auto attribute that. We'll turn off the in run because we only have an outrun on this deeper hole and not an in run. And then we can start doing some further analysis on the data. So one of the tools that's really powerful that we've recently implemented into ioGAS is a Wavelet tessellation algorithm. So this is an automated feature and boundary picking algorithm with the added functionality that it generates an output that's very familiar to geologists, which you'll see when I run this. So here we have a grouping field, which is just the drill hole. We've got 2 different drill holes that we want to run. With the gamma data, we have a single depth. So we set our from and our to depths as the depth. If we were working with interval data, you'd put the froms and tos here. For the signal column, we just select gamma. And the next piece is the interpolated spacing. So here we have the options of half, median, or median. In order to do the wavelet tessellation, it needs a regularized spaced data. And working with gamma data, we're working with 10 centimeter data. So it's very evenly spaced data, very close data. If you're working with geochemical data, where you might have various broader space samples or broader spaced intervals or variable spaced intervals, then it's better to check the half median. It just gives a little bit more flexibility on where it puts the boundaries. So right now, I'm not going to run the large hole. I'll just run the shorter hole just for time, and we can generate the tessellation. And here we can see that it's gone through the data. It's picked the boundaries, which we can see at the edges of the rectangles, and that it's put it out in a fairly familiar format to what geologists are used to looking at. And in this, there's a fair amount of detail. You can see, so along the x-axis here is the scale at the top, and then the gamma, which is just the scale for the gamma. But what this scale does is it shows the scale of the features or the boundaries that it's picking up. So on the left-hand side, it's picking up very strong features or very large features. And we can see in this, it's picked out basically 3 main features at the largest scale. And as you go to finer and finer scale, it picks out more and more features, and to the very finest scale where you get a lot of detail on what is picked out. So this suits geologists quite well because you can lump or split to your heart's desired. If you really want some broad looks at things, you can take the large scales. But if you really want to get into the fine detail, you can zoom in and go to these finer scales. In ioGAS, for each plot that you have, or each window that you have a number of tools that are on the right-hand side toolbar that are associated with this plot. So if you want, we can put a heat map on it of the continuous wavelet transform. We can show the boundary crossings for the interpretation of that continuous wavelet transform. We can filter at different levels. So what this does, it filters based on the strength of the boundary or the feature at the lower scale. So if we increase this, we start to lose some of that fine detail that's likely more noise than it is features in the gamma data itself. We can also change the coloring mode from just normal linear coloring scale, log coloring scale, percentile coloring. And this is good if you want to highlight certain features. What we eventually want to get to is we want to get to a scale that we think represents the geology or the features that we want to look at in the data. So if we select a scale here, so say 1, we can take the data at that scale 1 and write back to the data the value of the the mean of the rectangle that it falls into. And so what that does is it blocks out the data into those zones, and it removes all the noise. So if you just ran normal clustering algorithms, you'd have 5 different zones, or maybe 5 different clusters, but it would alternate between a bunch of the clusters because of the noise and the variation within the zones. Once we clean up this data, or essentially what it's called is blocking the data into these scales, it cleans up that process and you get a much cleaner output. So right now, I'll just select the scale of 1. I'll change the scale here to 1 just so it's an even number. Keep that filter percentage. And then if we select our variables here, we can just do a graph, do a downhole plot, and look at that and what that's done. So here we see the same plot. And we'll set the scales equal here. And we can see that it's taken the highly variable plot, blocked it out into sections, and we can now see that those are continuous sections at that scale of 1. So if we wanted to take that data one step forward, we could just just cancel that for 1 second. Select variables. We only want to use that block data. Go into clustering. Here we don't need to do any transformations. We can just do simple clustering. We can see that in this data, the knee of the plot falls at 6. So this plot gives you an indication of the number of clusters that best represent your data. So here we're gaining a lot of information in adding clusters. Once we get up to 6, adding another cluster does not change the data that much. It doesn't add that much more information. So we can just choose our K of 6 and apply it. And that will then take, and it will classify that data based on those clusters. So I'm just going to go back and repeat that on the larger drill hole, and I'll point out a couple of other features.
So as we're doing that, Fred, a couple of good questions. There's a bit of a conversation there with Ryan around API links between Hub and Sequence Central. We obviously have live links between Hub and Sequence Central for IQ logger data, so structural data, and also for survey information. We don't currently have it for Gamma, but it is on our roadmap. However, of course, you can use the live link between ioGAS and Leapfrog to look at this data and play around with it and do this kind of coloring, these workflows that Fred's showing right now. You could be having these classifications or these areas of the drill hole colored up in the Leapfrog model at the same time. So those processes are in place. And the other question, maybe one for you, Fred, is one of the other questions that came through was, can we see the coordinates of the tessellation, so that the boundaries as a table, basically?
Not at the current moment. Not as a direct output. There's ways of doing it, but not as like a one-click thing within ioGAS. But it is a good idea. So it's something that we can potentially look into putting it.
Yeah. So you're running one. We've got another question here while you're running that, because you can do 2 things at once, being a bloke.
Yeah.
Can you configure the parameters of the wavelet tessellation? So I guess that's fundamental, kind of mathematical parameters.
Yeah. So just let me start this for a minute.
So you can't do 2 things at once. I know this.
Yeah. Thanks, James. No, just not at the moment. So we've reduced the number of parameters that you can use, or that you can vary to basically, when you're outputting it, to the filter percentage and the scale. So these are kind of your accessible almost hyperparameters that you can tune just to get to your best view of your data. A lot of the other parameters that go into the tessellation, they'd be for more advanced users, I guess, than the typical users of GAS. So GAS has really been made to be to have accessible and safe workflows, so that anybody that's looking at data can use it and apply these workflows without getting overly complicated or into things that actually might cause issue and more problems in just going outside of what would generally be used. So all that I did for this drill hole here is, because it's such a large drill hole, so it's 2,000 or nearly 3,000 meters, and the processing time does get longer depending on the size of the drill hole. But here I've just filtered out, so window of data from, I just split the data into 10 equal depth ranges and looking at a depth from 1652 to 1943. Run the same tessellation. We can see here, I did do half median on this, so it might take a little bit longer, but here it is. So even with that at a half median, so that's equivalent to about a 600 meter hole, getting as much detail as you can within that. It just processes it in a couple of seconds. So here we can see, and again, it's a larger drill hole, so we've got a lot more detail sitting at 10 centimeter data. If we follow a similar process in this, except taking it one step further, we can come here, and if we wanted to set a scale at 1 or something, we can do the same thing. But what made me choose that 1, that scale of 1, was just my personal preference at the moment. But if we want to go back to this along the right-hand toolbar again, we can use a similar process to what we use for k-means clustering, which is just taking the sum of the squares of each data point to the mean of each rectangle that it sits in. And we can use the same knee plot or the knee position to generate that scale that best represents the data. So here it's 1.54. We can just click on that data point, and then that'll bring up this dialog box again, and we can generate that or write that data back to the table. So here I'll just change it again to a round number and do that. Created it. Select those variables again, cluster it. Here, so we're sitting 4 somewhere. Generally probably choose 4, but in this, I'm going to choose 6 to get a little bit more detail. Go to format to graph, downhole solid. And here we can see that data there. So we know here we've got some high blue ones, which are sitting in cluster 5. If we want to highlight those, we can just change those to red. And we've got another cluster here that's sitting in the orange. So then we can just take these off and just come back and look at the oranges and the reds. And this could be whether we're looking at little, in this case, the higher ones are little porphyritic units, and the orange might be related to alteration in this case. And so we can highlight those. And when we have that plot, we can take that plot along with the tessellation, print that out for a certain set of core boxes, whatever we're logging, and see those critical boundaries within the data at the scale that we've chosen. If we're doing a very large hole and we want to look at again, look at broad scale boundaries, we use the higher scale. And if we want to look at fine scale boundaries, we can zoom in and look at the fine scale boundaries as well. So I think unless,
yeah, so I think the key here really, Fred, is that, you know, this isn't a process around replacing the geoscientist or doing some of that stuff. It's about giving you an extra bit of information so that you've got this data coming in from the rig. There doesn't need to be anyone transferring back and forth. When you're laying those 4 boxes out, you immediately can see and hear where those critical boundaries are. And as a geologist going through and logging, you can see from a very quick workflow where those boundaries are, and then your decision then is around what's on either side of those boundaries, not what the boundaries are themselves. So it gives you that extra speed in doing your job.
yeah, and that's what's shown here. It's when you get that data, you plot it out, you see those boundaries. You can take it directly to the core. You can pick the boundaries in the core. You know where to look. If there's certain features that you're interested in, you can focus in on those features before you might focus in on the more general features that you might not be interested in. So just here showing a picture with some core, we've got a little snippet of about 15 meters showing some, these are dolerites with some little porphyritic units in there. But what we can see within these dolerites as well is you get a bit more of a halo or some alteration in the dolerites associated with those porphyritic units that you might not pick out. So that's one thing where it's really powerful, is looking at things that are more cryptic or not readily visible in the core. That
couple of good questions here, Fred. Just I know we're running short of time a little bit. So the question from Jerry here, talk about core recovery. Yeah, so for lower core recovery, how would this affect the gamma data? I guess the beauty of gamma, maybe we didn't talk about this enough, is it's a natural gamma logging tool. It can actually be run within the rods in the hole. So you're not an open hole logging technique, can be run in rod. So even if you're in really fractured and poor recovery ground, what it does mean is that you've got a consistent gamma signal down your drill hole, even at times when you can't recover core, or you're recovering poor quality core. So one of the nice things is a consistent data set that you can then feed back into doing what you can with the core that you do recover. So that's a great question and a great use of gamma in that way. We talked a quick question there about backflagging the results to the drill holes. I think Fred's shown the workflow there for classifying the data back onto the data sets. And of course, you can do some really fancy stuff at that point if you're bringing in other data sets and merging chemistry in there, those kind of things, where you can use the gamma boundaries, for instance, to start to define where maybe your assay intervals might be, or even starting to use those critical boundaries to define where you take samples for assaying. So there's some good things. Fault signatures, lithological changes. Look, it's all about the ratio of those 3 elements, but lots of features in geology will give you a shift in the gamma signal. It's why the oil and gas industry use gamma as their way of doing geological logging. So it's not something we've seen much in the hard rock minerals industry because of the complexity of deploying a tool. But now we've got a tool that can be deployed by the driller in the same way they run a survey tool. It now means that we have access to a data set that's been hard to get before, I guess. So, Fred, do you want to wrap up on anything else? We can circle back on any questions that keep coming in, either as part of this or after the webinar. We can email you.
Yeah, and I think James touched on a lot of this, a lot of those last 3 slides in those couple minutes. Just in previous slides, it was just the ability to, when you start gamma logging, you're getting these features in your boundaries, but you might not have enough information at that time. But when you generate these data sets and you combine them with other data sets, be it chemistry, mineralogy, things like that, you can start picking out the features and get more of an understanding of it. So you become even more well-informed when you come to your logging process. When you're in gas, you can although they're clustered into clusters 1 to 5, you can name those clusters, write that back to your data set, and then you have those tags back on that data. And really, in this, here I called it Geologist Plus, or it could be the Enhanced Geologist or the iGeologist, but really touching back on what James spoke about, it's not about replacing the geologist. It's about giving more power to that geologist and more information in his hands at the time of his logging, or at the time that he needs to make a decision. And currently the technology is available. The systems are in place to allow seamless and secure transfer of data. And the software and the analytics in the last few years, they've become more and more powerful, but also more and more accessible to the average users. And some of these workflows, like I've demonstrated, are quite simple, and you can get a lot of information out of them really quickly. And really, it's just about making the geologist more efficient and more effective in his job. So I think that's it for the presentation, for the formal webinar part. I'm sorry I got timed out of the IMDEX Hub, so I couldn't show you that, but we'll try to catch up or answer some more questions now, and see how things go.
I think we'll make an effort to pull together a workflow video that we'll make available on LinkedIn that shows that workflow again, so people can go back and look at it. Yeah.
So yeah, one of the questions there that was asked was, if you have 100 drill holes, you have to do them one by one. No, you can run all 100 drill holes at once. If you've got a decently competent computer with, say, 16 gigabytes of memory, it's not an overly intensive process. And you can either choose to do the selecting of the scale on each hole individually, or you can select a blanket hole and apply it to all 100 drill holes.
Probably one of the other things that just popped into my head then, worth pointing out to people, is that we've shown the use of wavelet tessellation as applied to gamma data. Wavelet tessellation is really useful, applied to lots of other downhole data sets, geochemistry, for instance, very, very useful for that, or time series data as well. So if you've got time series data in a processing mill, for instance, or something like that, you could use wavelet tessellation to understand the signal changes. And I guess the other thing to just quickly point out, for anyone that doesn't use or hasn't used ioGAS, you can actually go onto our website, download it, and get a 2-week trial to have a play around with it. Go and put your data sets in, have a go with these things. There's a very comprehensive help and instructions inside the software itself. Get in there, have a play, and just reach out to any of us if you've got questions or problems.
Yeah, and one other thing I'll mention is our next webinar that'll be coming up will be on ioGAS. So everybody keep an eye on their emails and sign up for it if you like, because as I mentioned, that it was one small feature of ioGAS, and Dave Lau will go through a bit of a broader look at what ioGAS can do.
So the webinar will carry on after the time that it ends, whatever time it is in Perth. I'm in the UK, Fred's in Perth. So if people do have other questions, so Fred, there's one there around case studies applied to iron ore. I mean, I guess that's
Yeah. So at the moment, we don't have a specific case study for iron ore. However, it's one of the typical use cases for gamma is iron ore. There's a lot of information on it, and the wavelets really do work well on that type of data, depending on what you're doing and what the patterns are you're looking at in the data. But yeah, it's a typical use case for the gamma, been used very successfully in the Pilbara and elsewhere.
So a question there around background values for the gamma. I mean, Fred's probably got a different answer to me. I mean, I think one of the key things about natural gamma is that it's a pattern recognition process, and it is consistent between drill holes. So as you start to drill more and more holes in the project area, then you start to build up your own understanding of the response of different lithologies or different alteration zones in your project area. You don't really need to worry about what a quantified value is for a particular rock, because it's so variable depending on subtle variations. So think about it like a pattern recognition, but consistent pattern recognition tool that you would use in your project.
Yeah, and so another thing on that is that we didn't mention is you can run gamma either open hole or in rod, and there's certain very well understood corrections that can be done to level out that data, but you have very, very small attenuation through your rods. So it's as effective in rod or outside of the rod, or sorry, in open hole. And
can we share the data and the question there from Rosemary? We'd have to look into that. This data is actually collected from an open file drill hole, but it's data that we've collected. I think, Fred, this data may be being provided back to the Geological Survey of WA. Is that correct?
Yeah, and then it should be available through them.
Yep, gamma survey in rods, absolutely. Yep, absolutely. The way this is done, Spiros. So the beauty of natural gamma is it can be done in the rods without any real impact on the quality of the data. So it's a really useful tool, particularly in those zones where you might lose the hole. So it's probably one of the few data sets you can collect that you can't get a tool down open hole. You can get the gamma in the rod. Yep. Really sequence. So I've got a question here. Can we filter the type of readings from hub to sequence central, so only visible in central the desired ones? Yes, there are ways of filtering the data that goes through the API to sequence central using the approved, pending, or rejected flags in hub. So yes, there are those mechanisms in place, and if you want more details, I can put you in touch with the right person. Just reach out to me. Okay. People seem to be diving off. Some of us are Fred's ending his day. I'm starting mine. Can the easy gamma be running RC holes? It's probably the biggest use case that we have. That we used in RC more than anything else, I should say, Fred.
Yeah.
Yeah, thanks. That's good.
So water in the hole doesn't affect the survey quality. It does have a bit of an attenuation on the gamma signal, but again, it's well understood, and it's a simple correction to correct it. But it's just a shift. It's not a reduction in quality, but you will see a little shift with once you reach the water table.
Max gamma temperature?
It starts, it's about 65 degrees Celsius. And then you start seeing the data be affected. So the tool's fine, but the data gets affected. The drill mud or filter cake, a small amount, but minor. Depending where you'd have an issue with that is if it's just a consistent filter cake, then you just have that added to your signal. If it's inconsistent, you might get some issues from it, but it'll be minimal. If you had really high KCl fluids, you'd probably see an effect in a shift in your data, but again, that would be applied across everywhere where you had your drill mud.
Yeah. Yeah. So it looks like probably the questions are beginning to ease up there, and people are kind of diving off to start or end their day, wherever they are.
Yeah.
So yeah, as always, you've got people around the planet that are available to ask questions. Like I said, I'm based in the UK, so I'm in this time zone. Fred's in Australia, so reach out to us if you have any more questions. We can help people out.
Yeah. And other questions can also be sent directly to webinars at IMDEX Limited as well. And for those of you that are interested, there's a certificate that comes out directly from GoToWebinar that'll be sent to you about an hour after the webinar ends. Okay. So I guess that's it, everybody. Thank you for joining us. And like I said before, our next webinar will be on ioGAS. So keep a lookout for that, and talk to you all later.
Okay. Thanks very much.